Okay, so let's go ahead and delve into 4.2. Trig functions of acute angles, 4.2. Trig function of acute angles. What is the opposite of an acute angle? Be an obtuse angle, right? An acute angle is angle that is less than 90. An obtuse angle is angle that is between 90 and 180, right? Okay. So let's say acute angle versus obtuse. So in an acute angle, let's say I had a triangle, it looks like this. Okay, an angle that looks like this, and this is A, B, C. And this is we're going to call this theta. What is sine theta?
B over C.
B over C, is that correct? What is the pneumatic that you guys were
It'd be B over C, opposite over.
Huh? What?
B over C, opposite.
B over C, SOHCAHTOA, right? SOHCAHTOA. You guys learned it as SOHCAHTOA, is that correct?
Yeah.
Long time ago, SOHCAHTOA. So, SOHCAHTOA, right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. You guys remember this? You guys are not taught this?
That was helpful.
Yeah.
Okay, anyway, so it's B over C, right? B over C. Therefore, if you continue with this, cosine theta, cosine is adjacent over hypotenuse. This is the length that is adjacent to this over that, right? So it's going to be A over C. Tangent theta is going to be equal to opposite over adjacent. B over A. Okay. The way I learned it eons ago was that if you look at your how to write an S in cursive, small s would go like this, right? Bottom, top, bottom, top, bottom, top. A C would go from here to here, bottom, bottom, top, bottom, top, bottom, top. Tangent, bottom, top, T, right?
Right.
T, right?
A cursive.
Yeah.
S as
B.
capital or lowercase?
So it's a bottom, top, bottom, top. Okay?
Interesting.
That's how I learned. I did not learn the SOHCAHTOA.
If it works, right?
Whatever works for you. Either one works. Whatever works for you, it works, right? Okay, can anybody tell me what the inverse of sine theta is?
Isn't it sine with a negative 1 as an exponent?
Oh, no. That is not it. Anybody else?
Dang, okay.
Cosecant theta is equal to 1 over sine theta. Therefore, it would be C over B. Cosecant theta. All right, over here, we're going to have a secant theta, which is 1 over cosine theta, C over A. It's a reciprocal, right? The reciprocal of tangent is cotangent. 1 over tangent theta. So it's going to be A over B. Right?
Never heard of it.
Okay, so now you have, these are the 6 basic ratios or trig ratios that you need to know for each triangle. Okay? Sine, cosine, tangent, cosecant, secant, cotangent. Go to page 329. There is a blue box that denotes that. See if it makes sense to you. Read it, please. Okay, so let's see if we can actually use this and do the isosceles right triangle. So this is example 1. So I have this guy and this guy is the same. This is a 45 degree angle, right? 45, 90. What was the ratio here? 1, 1, root 2, correct? Does this ring a bell? Like way back in
Oh, wait, I'm thinking of
geometry.
360/90, never mind, okay.
All right. So this is going to be 45. We're going to call this is going to, so this is 45 degrees, right? So what is sine 45? Bottom top, right? Over root 2. By the way, in my class, you can leave this like this. You do not have to change that to root 2 over 2. Okay? 1 over root 2 is perfectly fine. Cosine 45 is what?
Also 1 over root 2.
Bottom top. 1 over root 2. Tangent 45 is what?
1.
1, right? Bottom top, right? 1 over 1. Cosecant is going to be what then?
Root 2.
Secant,
Also root 2.
root 2. Cotangent, 1, right? What is 45 degrees in radian?
25.
Nope.
Wait, it's not 185.
It's 4 or 5.
Pi over 4. Pi over 4, right?
Yeah.
Because pi radians is 180 degrees, right? So there are 4 45s in then 180 degrees, right? So it's 4 pi over 4, right? Okay, so if I do this in radians, it would look like this, right? Pi over 4, pi over, right? Pi over 4. Okay, right? So what was the other special triangle? Oops. 60, 30, 90, correct? What is the ratio here? 1, 2,
Square root 3.
3. Right? What is 60 degrees in radians?
Pi.
Pi over
3.
3. Pi over 3. Pi over 3. So sine pi over 3 is bottom top. Cosine bottom top. Right? Tangent will be bottom top. Right? So cosecant pi over 3 would be what?
2 over root
2 over root 3.
3.
Secant
2.
2. Cotangent pi over 3. 1 over root 3, right? Are we good? This was example number 2, by the way. This is example number 2. I think that is example number 2. Okay, all right.
Oh, what's the conversion from degrees to radians? Is it pi times a degree or something?
It's basically pi radians is equal to 180 degrees. That's the conversion factor right there. Okay? You can use it however way you want to use it. Okay, example number 3. In example number 3, they're actually going to do something different, and they're going to give you one of the ratios, and you have to backtrack the other one. So in example number 3, it says that sine theta is equal to 5/6. And they want us to figure out the rest. Okay, so the way you would do that is you would construct a triangle. This is 6, this is 5, right? If this is theta, correct? Sine is bottom top, right? So it's 5/6, right? So if this is 5 and this is 6, what is this guy?
11.
What?
Isn't it root 11?
Root 11, right? Because it's root 36 minus 25, right? 6 squared minus 5 squared, right? 36 minus 25, root 11, right? So therefore, I can tell you what cosine theta is, right? Cosine theta now is bottom top, right? Tangent theta will be bottom top. Right? Okay. And then you would just flip these over to get the cosecant, secant, and cotangent, right? Okay. That would be the 6 basic functions there, right? Okay, and what do we have here? Okay, let's stop right here. We'll stop right here, and I'll have you start working on the homework.
Mr. On,
Yes.
for the tangent.